Here's an example of solving a problem using the semi-log plot to do the log calculation. Our question is, how many half-lives does it take to lose 90% of the radioactivity for a given radioactive sample? So we know that in decimal percent, 100% is 1. And I'm going to lose 90%, so that's 0.9. So I'm looking for when do I have zero point 0.1 or 10% left. The equation is log of the sample at some time t over the initial sample is going to be equal to a minus log 2 times the number of half-lives. And we're going to use this graph to solve this particular problem because we know in this case it's going to be log of 0.1 equal to minus log 2 times n. Now on this plot you can see that the scale on the y-axis here is in a log scale. So really all we have to do when we want to take the log is look for the number that we want to take the log of. That's 0.1. And note that the slope of this line here is minus log 2. So that's the slope. It's already taken care of that. And so basically if we go over to this point here, the 0.1, follow it over to where our line is, and then project that down. Try to do it straight. Then we'll get to about where that position is on the n scale, that is the number of half-lives. So we can see here that we have 0 half-lives, 1 half-life, 2 half-lives, 3 half-lives, and then this point right there is about, and I'll put a little about approximate symbol in there, it's about 3.3 half-lives. So if the half-life were something like 8 days, then the time would be something like 8 days times the number of half-lives, which is 3.3 as determined by the graph. And 3.3 into 8 times, that's going to be 26.4 days. So this would be an example of getting the time given the number of half-lives that we found from the graph.